All right, I think we're live again here on the Battlesnake Twitch channel. This is a late night Monday stream. We're trying to make sure we can hit different audiences and hit different people across Canada. So if you're tuning in and this is your first stream, awesome. Thanks for being here. If you've seen other streams and other workshops as part of this event, also awesome. Thanks for tuning in again and supporting us. Tonight we've got Aurora Walker again. From Bambora and Canada Learning Code, and she's going to be talking about early Battlesnake strategies and tactics. So we've got Aurora Walker here, and we're really excited. She's been a really good friend of mine, but also of Battlesnake, and a really strong advocate for what we've been doing. And she's going to be talking about early game, not necessarily early game, but early development strategies and tactics. This is kind of an extension of the workshops and tutorials we've been running last week. So last week, we ran a bunch of sort of earlier, like getting started, building your first snake, deploying your first code. There was a bunch of content and a bunch of workshops and tutorials for that. If you're interested in that, it's all available on Twitch, or you can go to play.battlesnake.com and there'll be links to all the VODs for those. What Aurora is focusing on is sort of the next steps. And I think this is awesome. I think this is some of the more interesting workshops that we're running. So I'll let her kind of talk about what those next steps look like. But this is kind of the theme for this week in terms of what we're doing on Twitch, is talking about what to do. Like, now you've got your snake deployed and you're able to kind of change its behavior. How should you make it behave? And that's what we'll be talking about this week. So with all that said, I'd like to welcome Aurora to the stream. Awesome. Cool. Are you there?
Hello. I am definitely here and super pleased to do this. This is our second run through. We got to do it on Sunday as well, but I'm excited for you evening crew folks to go through the strategies and tactics and get the hot tips that I have available for you, especially if you're just coming off of one of the beginner tutorials from last week. So perfect next step.
Yeah, absolutely. Can you tell everyone a little bit about yourself and your involvement in Battlesnake up till now, and then sort of where they can find you now?
Yeah, absolutely. So as Brad said, I'm Aurora Walker. I work on the technical team at Bambora, Victoria. I'm also a volunteer with Canada Learning Code. So I'm one of the chapter leads for Victoria. I love Canada Learning Code. It's a great, very similar organization in that it's for that early stage technical literacy. That's what Canada Learning Code is all about, running programming workshops and technical digital skills workshops across Canada. So hello to any of my Canada Learning Code friends who might be out there. And Battlesnake just fits in so perfectly with that theme and with that idea that I'm so passionate about, because Battlesnake is perfect for these next steps. It's like the next chewy problem. And something I really love about Battlesnake is it's like a really good German board game. It's so easy to learn and it's a lifetime to master. There's so much room here to really work on your development skills and build that up through Battlesnake. So I love participating in the Victoria scene, and I love that Battlesnake is something that came from here, and to now expand it to the online is really exciting and fun. So I'm glad to be here.
Awesome. We're super glad to have you, and thankful that you've been able to make some time and put this together with us. Mm-hmm. All right, I'll turn it over to you. And
let's dive in here. So I'm just going to bring up my notes. Oh, sorry. So I want to tackle today the next steps around building from your starter snake. And so this is something like Brad and I have talked about a lot, which are, what are the very first steps? Like, what are the first 4 commits that every snake should have? Because there's like a natural progression here. And I think there's like a great beauty in applying those like iterative development techniques to sort of taking your snake and starting to build it forward and make those like first few changes as that foundation before your long-term strategy goal. Because we see online and in the arena so many amazing snakes with different like approaches and strategies, but there's like a base that's really common. So if you've just come off of the beginner snake tutorial, maybe you watched like the Python one or the JavaScript one or something last week, this is how you go forward. This is how you start like really working towards a snake that's got a strategy and is of your own. So once we've laid down that foundation, I want to talk about some really common move strategies out there, how to recognize them, what to sort of start with. And then once you've got sort of this bit, what does the future look like? How do you kind of get to that next level? Maybe you've got an eye on that veteran category, so pushing for that. So I am going to show a little bit of code here today. I happen to work with the Python starter snake using like the totally vanilla deploy through Heroku. So exactly the way the starter snake README goes. But I'm really focusing on the high level concepts here. So it's written in Python, but don't worry about that too much. Python knowledge is not strictly required. But if you are into that and you do want to see my own progression and all of the little things I did when I built up my snake that I'm going to show here as a part of today's session, you can totally see that in my GitHub repo. So my username is just Aurora Walker, and you'll see the starter snake Python, and you'll see all my commits and all the messages and all like the little mistakes and gotchas that I ran into. So absolutely check that out if you would like. Cool. So the big secret, the first 4 commits that pretty much every snake should have are these 4 things. Your first goal should be to not run into walls. That is a great starting point. That is a perfect starting point. And once you've mastered that, then you can start worrying about the more complicated things, like not running into yourself as a snake, because you can hit your own body, or running into other snakes. And finally, the food issue, like you don't want to starve. There's a life cycle, and like you need to eat food eventually. So these are sort of like the first 4 commits, first 4 problems you need to solve when you're working on your snake. And once you have this foundation, you can start building onto more complicated things. So even before you start writing code, though, I really want to endorse reading the freaking manual. I don't know. This is like one of those things I'm really big into. I like reading. I like understanding what's going on, but there's like a wealth of information in there. And you want to go into your programming armed with all of your knowledge. So there was 2 things when I was reading the Battlesnake docs, which URL's right there, docs.battlesnake.com. That stood out for me. And the first was the orientation of the board, because maybe you have a similar background to myself. A lot of my education is sort of like mathematics based and like a sort of Euclidean geometry system. So I assumed at first that the origin of the game board would be in the bottom left-hand corner. But it turns out in other systems and other industries, the origin can be in a different location. And that's the way that the Battlesnake API expects it. So the 0, 0 on the XY coordinate system is actually in the top left-hand corner. So this is an important fact. And if you're just sort of like writing code and like stumbling along and kind of figuring it out, or coding by accident, as I call it, you might not see this, and this might not be a problem, or this might be a problem in your code for quite a while before you recognize it. So definitely take a look in there. There's a lot of juicy tidbits and information on the game rules and what to expect. And that was definitely something that I needed to learn. And the second thing I want to highlight is take a look at the game object. So there's a JSON object that the API returns on pretty much every call that tells you information about the board, about the snake, where food is. And you need to become very familiar with this, because this is the core of all of your programming challenges, especially like at the early state, and especially if you're a little bit new to programming. So making sure you know what data is available to you, where it is, how to access it, that's going to be crucial for making decisions and kind of anticipating problems and things you need to solve. So I've been in web development using Python for about a decade now. So I'm very familiar with JSON objects, and I'm really comfortable in interacting with dictionaries in Python, which is how I know I'll interact with this. But maybe you're working in a new programming language, or maybe you're doing those for the first time. So I would even like to encourage you to take a step back and make sure that you understand what tools are available in your programming language. How do you interact with JSON objects? How do I access pieces of data and manipulate them? When we're doing iterative development, there's a cycle. And to sort of simplify the cycle, the way I like to think about it is, your first step is to learn, your second step is to apply, and your third step is to get feedback. So anytime you're solving any problem, you need to learn. what kind of information is available to me, what do I have for resources, apply, what code do I write, how do I solve this problem, what am I trying, and then feedback. Did that work? Was it almost there? Do I need to make a change? And just kind of repeat that cycle of learning, applying, and feedback. So don't neglect the learn phase. And you've got lots of resources available, whether it's the documentation, whether it's going to the Slack group, or interacting with the community to kind of learn stuff to solve your problems and help get a bit of a boost. Cool. So with that said, let's talk about our very first step, which is don't run into walls. So let's take a look at the code that I've got here. So this is the Python starter snake, and I've made a few modifications right off the bat. Definitely adding some, new print variables just for my kind of standard, easy, quick debugging. But the very first thing I wanted to do when I recognized I didn't want to run into the walls is I need to know where the wall boundaries are. And as I saw in the JSON data structure, the board width and height are sent to me. So I just threw together some really quick global variables so that I can store that, and it's easily accessible from all parts of my program about how wide and how tall the board is. And I did store them in different variables. All the default Battlesnake boards have the height and width the same. It's always a square. But I'm a suspicious person, and I work for Bambora, and we definitely do bounty snakes every year at the on-site Victoria event. So, I wouldn't put it past people to kind of mix it up and maybe have a rectangular board or something. So I'm definitely going to store these separately and kind of plan for the future. But I've tossed these into some variables. Now, you might say, Aurora, aren't global variables bad? Well, I mean, nothing is truly bad or good in this world. There's always kind of shades of gray. But I want to emphasize that I'm doing iterative work here, and I'm throwing together something quick just to kind of proof of concept and check it out. I do have some practices that I like to enforce. So I created a new file called globalvariables.py, where I am storing these values, so I'm not accidentally overwriting them or having trouble importing them. So it's a lot more central and a little harder to make mistakes or do some of those problems or challenges that often happen when people stumble using global variables. And I mean, I've got a lot of experience using Django as a Python web framework. So now that's just basically a settings file. It's fine. Don't worry about it. It's cool. But I've got these stored. And I've also done the ever important configuration of what my snake looks like, modifying the color and the head and tail. Definitely talking with some of the Battlesnake crew. Hearing about this is a really great debugging technique, because you can always just change your head or your color just to kind of validate that you've made a change and that it's in the board that you're, or the games that you're looking at, because it's a sanity check to sort of verify that your code has in fact changed. So kind of a neat little Battlesnake hack there for you. So that's some pretty lightweight stuff, but where it gets kind of juicy, where I'm starting to make my changes, is in the move function. So one of the first things I did, we get by default the entire JSON object, the entire board state. And I just started by pulling out the current head of my snake, because that's what I need to control. I don't want it to run into a wall. So I need to know where my head, my snake's head is. And I've got the random move. So I'm going to leave this here. When I started thinking about how I wanted to organize my code, I decided there was kind of two components to it. There's going to be the logic of my program that decides, well, where am I going to go? What's my strategy? What do I want to take for my next move? And then I wanted to have a section of my code that's kind of a sanity check. That's okay, my code has proposed this as the next move. This is a possible future state. Let's verify that that's safe. Let's verify that that move is not in a wall or in another snake, and make sure that it's not a move that's going to end up ending the game for us. So the first bit, I'm not going to modify too much right now, is this strategy, which right now is random. So yeah, go random. It'll pick one of up, down, left, or right. And then I'm going to start writing my strategy to avoid walls. So let's dig into my avoid wall code here, which is just in another file that I sorted out to kind of organize. So avoid wall is a function I've written that will just return a Boolean true false to say whether or not the move that's been proposed is actually safe. So it'll take the current head location, so where my snake's head is right now, and it'll take the move proposed by my choice algorithm, which currently is random, and it'll tell me whether or not it's safe. So for this one, for the avoid the walls, I'm just going to take a look at it and predict what the next position of my head would be if that was the move we were going to make. So the head is stored in like an XY coordinate. And I've written a little helper function called predict future position that will tell me what I get out of that. So left, right, up, down is kind of hard to parse. I want to know on an XY grid, what is that future state? So just to sort of like write that out a little bit explicitly, if I know that the head is located at, X1, Y2, whoops. So this is just like a Python dictionary storing the data. So this is kind of the data structure format that I'd expect. I want to know if left and right, what that looks like. So maybe if it's going down, then the next future move would be y is equal to 3. So that's what predict future position is going to return, and that's what it takes as input. So pretty straightforward. I had to sanity check this myself because the documentation for Battlesnake wasn't totally clear. But if I move left, that's going down 1 on the x coordinate. If I move right, it increases the x coordinate by 1, and same with y. Going up will reduce y by 1, and going down will increase y by 1. So now that I've got this helper function, it's going to be useful. I got a good feeling about this function that I'll be able to use it quite a lot. But it'll take the current location of the snake head, the next move, and tell me what the potential future XY coordinate of the head would be. And then this can tell me whether or not it's safe, because of course, if my future state is, -1 on the x-axis, then that means I've hit the wall. So I can just do a real quick check here, checking for the board maximum on the x and y axis, as well as the minimum, which is 0, and let me know whether or not it works. Cool. So this is all I'm going to do for now. I mean, it's highly likely that my snake will run it to itself or starve, but this is as far as I'm going to get, just to kind of verify that I'm not running into the walls. So I've already pushed my snake up to Heroku, and I can actually start a game and kind of like test this out and verify that this is working. So I'm going to create a game here and just add one of my own snakes. And I'm going to use a small board just to kind of increase the likelihood that it could run into the wall. So I can, or the likelihood that it'll go to the wall and then leave. So I will run this game and see what I get. Cool. Okay, so it collided with itself, which is pretty great. If I go backwards here and I just play through this, okay, so it didn't run into the wall, but it didn't get really close to it either. So I just kind of want to create a rematch here and just see, this is a good starting position. See if it deliberately avoids the wall. Okay, it's colliding with itself. So you can kind of like guess and test like this a little bit. I would also, hit the wall there. There's a problem. I would also recommend taking a look at your own logs. So I have my Heroku logs here, and it'll tell me the output, and I can kind of follow and see through print statements whether or not it rejected an option correctly or not, whether it like considered going to a wall and said false. So I can sort of like force this and kind of validate it. Now, in this last snake, you'll sort of see I definitely hit the wall there. So I know that there's a bug there, a bit of a spoiler. We'll dig into that a little bit later. But through this method, we can kind of like guess and test and go through the process of making sure that we're not hitting the wall. So that's your first milestone. Super okay to create a game that's just your snake so you can validate this. Awesome. So once we've solved this basic problem of don't run into walls, and we've set up our code structure, so I kind of like this format of my choose a move code and then my validate that this is safe or not. So this is pretty comfortable for me. I think I'm ready now to start tackling the don't run into yourself problem. Cool. So not running into yourself is going to require a bit more information. I'm going to have to take a look at the data available to me and kind of check where my snake body is. So just going through the history of my code here, I'm going to advance here. Oops. Oh man, can't switch to my branch for a second. Oh, okay, I got some changes. Cool. Awesome. So switching, moving forward in time here on my code changes. So last week, Aurora was writing Snake code and moving through this and kind of making changes and seeing what's going. So my very first attempt at modifying the code and getting to a state where I wasn't running into myself can be found here. And once again, like you can see all of my little commits in my GitHub repo. So this is my actual Git commit history. So down here is the last commit from Brandon when I forked my repo from the main Battlesnake Python starter snake, and I started, slowly going through the process. So there's my first attempt at avoiding the wall strategy, and now we're taking a look around up here somewhere, just sort of adding logic to prevent running into myself. So at this state, things are mostly the same. I'm still checking the board minimum and maximum exactly the same, and I'm still using the random move strategy, but I've kind of modified my functions a little bit. So instead of just checking for the wall, I'm going to validate the whole move. And if I don't get sort of true that it's safe, it's going to continue to pick randomly from up, down, left, and right. So taking a look at my strategy code, predict future position is pretty much unchanged. Like, it's working, it's doing the job. And avoid walls is also pretty much the same. But I've added two new functions here. One called stop hitting yourself, which in retrospect was a pretty poor name. I don't know, I guess I was feeling kind of clever at the time. But this is following the same sort of pattern as not running into the walls, which is I'm going to return true if the move is safe. I'm going to return false if it is not a safe move. And I'm going to use my predict future position function to kind of verify that the future head state that's being proposed doesn't violate this. So that's all combined in this function called validate move, which is going to do both of those checks. It's going to see, hey, does this move avoid the wall? And then, hey, does this move avoid running into myself? And if both of those things are true, if both of those are safe, then it'll return that it's safe. And then we can kind of proceed with that move. So this is where I started. I definitely had to do a little trial and error work, especially with the future head and trying to kind of figure out how this all works. Python is a fun language here. It makes reading this really easy. If future head in your body, but to just sort of expand on what's actually happening with the code, we know that the head data looks an awful lot like this. So we'll have an X coordinate, say X1, Y2. So this is the head location. And then we know a snake body, if you take a look at the JSON dictionary that's, or the JSON object that's returned to us from the Battlesnake server, is that we end up with a list of coordinates. So in Python, that looks like this. And I had to do a little bit of trial and error to confirm this because the documentation wasn't totally clear on this. But I've learned that the first value is a snake's head. The second is its body, and then whatever the last one is its tail. So altogether, this list represents the entire snake length, every position that my snake takes up. So what's kind of nice about this in Python is I can just check to see if this coordinate system, this dictionary X1, Y2 is inside of this list. And if I can validate that, then I know it is going to hit a body position that's already occupied. So in Python, it looks like this. In a different programming language, it might look a little different. So you just need to adopt this logic to whatever syntax of whatever language you're using. But that's kind of the general idea. Cool. Awesome. So I ran this ago. And I'm not going to run this code because I definitely got into some sticky situations. There was definitely some bugs in here. So I took another stab at it. I ran my snake a whole bunch of time. I tested it in the arena all by itself. I watched my logs, which were critical, and I had to put a whole bunch of more debugging print statements in. But eventually I got to a new version. Cool. So after a bit of work here, one of the first things I did was I renamed my function because there's no points for being clever. At the end of the day, having good readable code that's easy to understand is always an advantage. Do future you a favor and write code that's easy to read and understand because your past self could be your ally or your greatest enemy. And I prefer to do favors for future Aurora. So I had kind of a really big bug in my code, which was in each of my moves, I was doing something really unnecessary, and something that ended up being very confusing was that I was predicting the future position twice. So both in checking, avoiding the wall and avoiding the self. So that was one of the first refactors that I did, is I'm only doing the prediction and figuring out what the future head location is once. So that was a modification to validate move. I now pull out the future head. I call safe wall or avoid wall and avoid self. So that's one of the first big issues. And I did a little refactoring here because I was playing around. So I simplified my logic in avoid wall. I had like those stacked if statements. This is a little more concise. And it's also a little bit more optimized. So one of the properties of Python is if that first condition is false, if it fails, then it'll exit immediately. It won't check all of the other states. And I kind of have in the back of my mind that 500 millisecond check, like that limitation in the API call. If I'm not returning my answer quick enough, then the server will move on without me and won't wait for my snake to respond. And I did the same sort of thing in my predict future head code as well. Just sort of optimizing that a little bit and trying to make sure that I'm up to date. And keeping everything quick, because I wasn't sure if I was timing out or not. Cool. So after a bit more refactoring, because this still wasn't working, and I actually got into this like weird infinite loop. So for a debugging period, I actually limited my loop for 10 loops so that it would only go 10 times, because I learned very quickly that I got into an odd state. My print statements were showing I was having like -100 x coordinate, -100 y coordinate. So to protect myself, I limited my loop, which is very, very clunky. This is not what I would be writing in production code, but this was enough to sort of like, iteratively move through and feel out the problem, and sort of debug and figure out what was going wrong there. So a little rough, but this is the progress that I made. I knew I had an error somewhere and I hadn't quite solved it. This is also the point where I learned how to kill a Heroku deploy, because I couldn't redeploy my snake because it was still busy. So I had to kill that program and got to do a little learning and documentation reading on the Heroku site, which was super fun. So let's take a look at the final solution here, and we'll actually run this snake. I'll walk you through where my bugs were. So I actually ended up finding 2 bugs here. The first was that I had an off by 1 error on my avoid running into walls code. So that's what sort of triggered the bad snake that we saw earlier when I was kind of running and testing the snake. When I was first writing my code, I guess I got lucky or unlucky in that only ever hit the top or the left wall, and I didn't really see it hit the right or the bottom wall. So it was really only hitting that 0 condition and not the x is 15, y is 15, or whatever the size of the board is. So I had to do a -1 on both of these, because the maximum x coordinate, if your board is of size 15, is actually 14, because the grid goes from 0 to 14 when the size is 15. So classic off by 1 error. You'd think after 10 years of development, you would stop making mistakes like this, but you never do. You just get faster and faster at recognizing when you've made this very common mistake. So that was one of my bugs. And then my other bug was a little bit more subtle and a bit of a Python specific issue, if we're being critical here. But in my predict future position code, the way it looked before was like this. So future head is current head. So my intention, my goal, was to make a copy of the current head location and then just increment it appropriately, depending on whether it was left, right, or up or down. And what I had forgotten, conveniently, was that in Python, when you do this with a dictionary, it's not actually a copy. It's more of a pointer. So when I was modifying future head, I was actually modifying the current head version as well. So if you want a true copy in Python, you actually have to explicitly call copy. And that was what was going wrong with my loop, was I was getting into a state where I kept modifying the current head location, and then it would get confused and get stuck. So definitely a subtle bud. My goal isn't here for you to learn, the secret Python, gotcha around dictionaries, but more to like really challenge assumptions when you're writing code and you're debugging. Because you think when you read something, you know what it does, but always challenge your assumptions, always test, always validate. Something I tell my developers a lot is don't just think something, know something and prove it however you can. So go through and check your assumptions, verify, validate. That's a lifelong coding skill. Trust me on that one. So I managed to get there. I managed to fix my 2 bugs. In there, I was definitely playing around with my code organization and putting in some comments. I was talking to myself in the comments as well and noting that my avoid self function is pretty basic. At some point along the line, I kind of recognized that as I eat food, my snake gets longer. And if my next move increases the size of my tail, then that means my next move is going to occupy more space than I thought. So I was like, okay, I'm not ready to solve that problem yet, but I'm going to write a little reminder for myself. And yeah, definitely played a lot with my print statements, trying to get my debugging tighter. So cool. So let's take a look at this snake and see how it performs. Like at this stage, I'd solved my bugs and I had a snake that wasn't going to run into walls and I was pretty confident wasn't going to run into my body. So let's push this up to the server. This is a nice tip. Using this colon notation, you can kind of push a branch other than master up to Heroku. So I'll do that. Let this build. Slowly but surely, wake up that Heroku server. Almost there. And I was pretty pleased with the snake at this point. Once I started kind of playing with this, and especially when I increased the board size, I was more able to get closer to like 100 moves. And this is a really good milestone to hit because once you hit here, you're not running into walls, you're not running into yourself. And if you're playing games where you're the only snake on the board, it really means that starvation is probably your biggest challenge. So let's create a new game. Let's make the big board a little bigger here. So just myself again, I'll start this game and give it a go. And oh yeah, look at that snake. So, I mean, I'm hoping I'll stumble on food before I starve out. Oh yeah. But look at it not run into that wall. Look at it not run into itself. After, wow, we're almost up at 150 moves. You would expect it to have randomly run into itself if it was going to, or randomly run into the wall. So I'm pretty pleased with this. This is a fantastic milestone. Oh, there we go. So taking a look at the final termination here. At this point, Snake had 2 choices that were safe, up or down. It randomly chose up. And as soon as it moves forward once now it's trapped. Now there's just literally no good choice. So at this point, it would have hit the maximum 10 checks that I have in my for loop, which is after 10, if you still don't have a move, then you're going with whatever. And at this point, it runs into itself finally. But it really didn't have a choice. So this is great. I feel really good about the snake. And as long as it's an arena by itself, it's going to do awesome. Cool. Oops. All right, so this gives us 2 milestones. Like we're halfway through the first 4 commits every snake should have. Don't run into walls, don't run into yourself. And I was seeing this really constantly. Testing the snake over and over again was I'd get into a position like this where I really only had 1 move, and then after that there was nothing you could do. So excellent milestone, good place to feel proud. So the next objective, now that we're not running into ourselves, what happens if I add other snakes on the board? Well, I'm probably going to run into them. So my next goal is to not run into other snakes. So let's take a look at the code. So while I spent probably half of all of my development time working on the avoid self code base, and especially exposing that error that I had with the running into the walls, this next iteration, this next commit came a lot faster because not running into other snakes is an awful lot like not running into yourself. So taking a look at my kind of base server code, once again, very, very similar. So now I have my correct boundaries for the board state. So I'm saving those in the start function because I know right at the start, I only need to check this once. I mean, maybe that's a good point. Like, you don't have to put this code in the move. You can just do this once at the start of the game. And then in my move, I still have my JSON object. I'm pulling out a bit more different information. So I had to make sure to look at the JSON data in the documentation and kind of verify where the information was. But I learned by reading that in the board data in snakes, there's a list of all of the snakes in the game. And I was pulling out my own snake's body explicitly because that was some information I wanted. And I still have my janky for loop here, just doing 10 checks, hoping that in 10, I get a valid, 10 guesses, I get a valid move. I'm still using my random choice function. So, just randomly picking a direction. And here's my strategy, validate move. So that's where all the magic's happening. This is my logic for verifying that it's safe. So I could have, and in fact, when I started, I was about to write a third function in here: avoid walls, avoid self, avoid snakes. But then I realized avoiding snakes is the same as avoiding myself. So I refactored again, and I took my avoid self function and made it more general to avoid any kind of snake. And that's the only change here. Beyond that, I'm still pulling out my current head. I'm still predicting my future head using my exact same predict future position code. That helper function has been a star for me. So I had to do a little bit of work here. If you remember, this bit right here, that was almost all of the code. I mean, it was a little simpler. I used a different variable name here, but if the future head is inside my body, return false, otherwise return true. That was the way the function looked before. Now all I have to do is iterate through every snake on the board and just kind of verify that that's true. So it was really just adding one line of code. And something that really helped me here in my comments, I'm definitely a comment writer, I like to write little notes to myself, is I gave myself a hint and a reminder about what this data looks like. So my avoid snakes function takes two parameters. One is the future head. So that's that same XY coordinate that we've been working with the whole time. And now I take snakes' bodies. So that's the list of all of the snakes on the board. I'm still going to return true if the move is safe, false if the move is unsafe. But I started, as I started to think about this, I was like, oh man, I need to expand this. Like, what are my next steps? So I saved these as comments instead of, trying to do too much in one go. But I noted, like, I want to check to see if any heads are about to eat food. Is that going to make the snake grow? I was also worried about snake tails leaving in the next move. So let's say I'm right behind a snake. And when I do my check, it looks like that square is unsafe because there's a tail in it. But in the next move, when I take my next move, that space will then become free and available. And that's actually really great, especially if you want to chase your own tail. So I didn't account for that yet, but I definitely put a note for future Aurora to be like, oh, hey, what about this? Think about this option. But to stay focused and to kind of test my base case, which is just don't run into bodies, I wrote out the Python data structure that it looks like. So if you look at the documentation, you get a list, and each snake looks very much like this. So it has an ID, it has a name, it has a couple other variables, but the one I care about the most is the body. And I know that the first item is the head, the body, and then the tail. So this represents one snake. And something that I had to find through experimentation, because it wasn't explicitly called out in the documentation, was I realized when I was reading my debug statements that the list of snakes that come from the board game, it includes yourself. So when you take a look at the documentation, just to kind of pull that up for a second. So here's take a turn, and this is the data you get back. So you get the game, you get the board, you get the list of snakes, but you also have this like little section for you. When I started this, I thought I would have to pull like my snake out from the you section and then add it to all the other snakes. But what I did learn was that this list of snakes contains all the snakes, including yourself. So that was a huge relief. That made this a lot easier for me. So it definitely helps to look at real data, look at your debug logs, see what you actually get, because that can really help you out. So once I learned that, I realized I had this collection. So all I needed to pull out was the body data. So that's what I've done here. So for snake and snake bodies, if the future head is in the snake body, I'm going to return false. So this ended up being pretty quick because it was so similar to my previous code and it covered all of the cases I wanted. So let's push this up to the server and see how it does in an arena with more than one snake. So git push Roku, void snakes to master. So we'll just let this go. This is pretty exciting. Like what I'm hoping for at the end of this is I've got my snake in the arena. I've got, 2 or 3 other snakes. It's not running into walls. It's not running into itself. And if it can help it, it's not running into other snakes. And I know that I haven't done anything to prevent it from getting inside of a sticky situation. So I only want to see it violate those rules if it literally has no other choice, that there's no safe moves to make.
Hey, Aurora, I'm just going to interrupt with a question here for a second. Yeah. So you were showing the snake bodies of length 3 with like the head and the body and the tail. If they're longer, what is that array going to look like?
So it really just expands. I only have them of length 3 because it fits on my screen. But it ends up looking like this. So it's kind of like if the snake is of length n, your 0th entry in your list is your head, your n-1 entry is the tail, and everything in between is the body. So that is typically how it looks. And that's okay, because this logic, the way I've written this code to just sort of check to see if the snake or if the future head is inside the body at all, you don't have to worry about how long other snakes are. You just have to check. So yeah. But yeah, that's a good point. I kept it down to 3 just because it fit on my screen really nicely. And I think in the very first stages, you might know this better than I do, Brad, but I think when you start right away, you're actually of length 2 because you're kind of compressed. But I can't quite remember.
I think you're actually length 3, but you're all on top of each other. So it's possible that those coordinates can be equal. So you actually have 3 body parts that are stacked at the beginning.
Nice. That's probably what we've seen there. There we go. Yeah. Cool. Good question. Thank you. Yeah, it's amazing like what you show and what you put in comments, just because it fits or because it makes sense. But like these are the types of things we want to question and ask and double check and like validate as we're working. That's what iterative development is all about. Like, guess, test, look, explore. All right, so let's create a new game. So here's my basic strat snakes. I'm going to add 5 of these guys. That's great. And a medium board, so fairly confined. And start this game. Let's see what we get. Play. Whew, okay, we've got some collisions already. So this is great. I'm actually delighted to see lost head-to-head, because that is not a state. That is not something that we have accounted for. So if they both ram into each other, that's pretty okay, especially if they didn't really have a choice. I'm just going to go back here. So this snake at the top here, it didn't have a choice. It got into a sticky situation. It had to run into the wall. So its termination there makes sense. If we go back a little bit more here, see another. Ooh, a lot of moves in this game. Here we go. Let's take a look at what happened here. Okay, so this is interesting. So the snake on the right could have gone up or down. Those are both valid moves. But the snake on the left could have gone right or down as well. So it's kind of like bad luck almost that it couldn't predict the 2 snakes were considering the same spot as possibly safe, and then it resulted in a head-on collision, and one of those snakes was smaller, so it didn't work out. So that's an interesting use case there. So something to kind of keep in mind. But if we look at the basic rules, the snakes are adhering to them. They're not running into the walls if they can help it, and they're not running into each other if they can help it. It's just when it's kind of ambiguous, like right in this moment here, when that square looked safe and it wasn't unsafe until the other snake moved into it at the same time. So that's a pretty cool state to go in. So I feel great at this point, actually. And I ran a lot of games because I was pretty exhilarated and thrilled at this point to have this happening. And seeing this a lot, like seeing a lot of head-on collisions or seeing the snakes either run into walls or each other when they really had no other choice. There was no safe moves to make. So this was pretty exciting. And I'm kind of confident. And I actually took basic strat snake and I put it into the veteran Battlesnake category for this very competition. And at the time, I was not last. And I'm willing to take a look right now. Let's see how the arena is at this moment in time. Veteran. So my team name is Hermit Colony, which I feel is very appropriate for the current times. And Hermit Colony is still 18 out of 21. 18 out of 21, and it's at the exact code state I've just shown you. So all this snake can do is not run into walls, not run into itself, and generally avoids running into other snakes except when kind of stuck. So I think that's really encouraging. Like, the veteran category is full of some very impressive snakes that I have seen a lot of, especially during like the Winter Classic. I mean, who do we have here? Oh, thanks, Microsoft Update. We've got, Swedish Vikings. We've got Secret Snake. We've got Jake. Like, these are some really great snakes here. The Medusa. Oh, goodness, it's intimidating. But here is Hermit Colony with like basic strat snake. Not last. So way to go, basic strat. And I think this is really encouraging. Like, this is a good position to be in. And I mean, there's definitely a degree of luck in Battlesnake, but just hitting those basics really kind of covers you for your foundation, and it it can perform. It can perform for you. So if we're not running into walls, we're not running into ourselves, we're not running into other snakes, the last sort of problem to solve is to make sure that you don't starve, because you can see that life ticker checking down every move. And this is kind of interesting because I started thinking about, well, what does that commit look like? And the food milestone is a neat one because it's where we really realize we have to start thinking about strategy. Because when do you want to eat food? So a couple of things about the board state. You know where food is location, or what food is located where. You've got that XY coordinates. You know where the head of your snake is. You can kind of move towards it if you want to. But do you want to eat food only at 0 health? Reading the documentation, we recognize that 0 health is is a period where you can live briefly. You've got time to eat right before that last tick down. But maybe you want to start eating below 20 health. Maybe you want to go greedy and eat a lot of food and get really big. But is there such a thing as being too big? What does that even mean? So one thing I observed in all of my testing was that usually I eat enough food by accident, that maybe I don't need to focus on eating food too much until I've really decided what I want my primary strategy to be. And that's where I'd like to transition this from that kind of code and early organization to really think about, like, how do we want to proceed forward? And in my infinite wisdom, having watched many battle snakes and seen many of the great snakes out there, that there's kind of 3 main categories. The first is random or chaos snakes, as I like to call them, which is actually what I have right now. It's pretty unorganized chaos. It's just randomly picking, left, right, up, down. It's got a couple of boundaries to prevent it from doing something really foolish, like running into a wall. But other than that, there's like no rhyme or reason to what it's picking. And I kind of love chaos strategies because there's something to be said for an amateur just defeating a master. Like, if you have a really advanced snake that's looking for strategies and like looking for common patterns, and it's trying to predict your behavior so that it can kind of justify its own choices, then it's going to have a hard time if you just randomly pick things. So I kind of love that about chaos snakes. I think it's a really cool approach, and it performs decently in the arena, so that's pretty good. I also love defensive based snakes, and I think everyone should write the standard de facto defensive snake, which is chicken snake. So we'll talk about that one a little bit more in a second. But if you're not going chaos and if you're not going defensive, you can also start producing strategies that are very deliberately attack based. And there's a couple of ways to tackle that. But these are kind of the 3 categories and the 3 areas you want to start thinking about your snake and how you want to approach all of your decisions from now going on. So yeah, pure chaos of random is fantastic. And what I've got is decent, but I can already think of lots of ways to kind of improve my snake, just based on the random move algorithm already. So the first is I don't want my code to kind of randomly reconsider the same moves. So if you remember correctly, I've got that kind of like clunky for loop where I'm just doing 10 guesses. And the reason I'm doing that is because there were times when my snakes would, run into a wall or run into itself because, let's say it wanted to go left and it randomly selected left and left was dangerous. And it would be like, nope, left is dangerous, try again. And then random said, well, what about left? And I'm like, well, no, left is dangerous, try again. It was like, have you thought about left? And so it just randomly considered a bad choice over and over again. So I could get rid of that awful loop and get some efficiencies, because I also don't want to hit that 500 millisecond check. So make sure that we're not randomly considering the same moves over and over again. Another thing I might do with the chaos snake is to think about avoiding food so I don't get too big and kind of spin it on myself. When you're moving randomly, you kind of have a higher likelihood of just kind of spinning it on yourself and trapping yourself. So I might try to stay small, but I mean, maybe I want to try something different and get really, really huge and kind of throw my random weight around. So there's some choices to be made here. I really love this basic random move chaos, and I want to do a bit of a shout out to Niels, who is the developer of Ravioli. And Ravioli is an exciting snake because Ravioli, hearing Niels talk about this, it sounds like Ravioli really kind of grew this way as well. This like iterative process, hitting these basic statements and kind of just like going forward in this way. And in the interview, he talks about how like every time his snake made a mistake, he would just make it never do that again. So just like watching games and checking for that. And we're kind of on that path already with the snake I've built. So definitely check out YouTube, definitely check out the developer interview and hear what Niels has to say about his experience in this journey of the commits and producing a snake for the first time that won the rookie division of the Winter Classic. So shout out to that, and definitely take a look at that if you're hoping to learn a little bit more and hear what other developers have experienced before you. So on defensive snakes, I want to talk about Chicken Snake, which is famous in Battlesnake lore. And to tell a little bit of a story and have you guys indulge me a little bit. I know the developer of Chicken Snake, Rob, because we worked together at the time, and I remember him talking to the team and being like, hey, what if we made like a company team and entered in Battlesnake? Like that'd be kind of fun. And we're like, yeah, Rob, that sounds like a great idea. We would love to do that with you. And then the date for Battlesnake comes along, and it's like the Friday before, and we're at work, and Rob's like, yeah, so I'll see you on Saturday at Battlesnake. And we're like, oh, dude, I'm sorry, we can't go. And we all bailed on him. So we had this idea of having like a company team and us all going and like building the snake together. So Chicken Snake is what he built. Chicken Snake is what gets built when you thought you were going to be building a snake with your buddies and they all ditched you at the last minute. But the amazing thing is that year Chicken Snake was a new strategy, and it actually did very well. I think if I remember correctly, it came like second in its division. And the reason why is it has like such a classic, beautiful defensive strategy and some broad rules that anyone could write. So the first rule of Chicken Snake is to generally avoid food so you don't get too big, so you can kind of hide. And you just like spin on yourself, chasing your own tail. And you only go out and get food if your health is like less than 20 or less than 10 or some threshold that you pick. And then you just follow your own tail as much as possible, probably in the corner of the board. And just make sure to take into consideration when you eat food to kind of make sure that you like double check that you don't run into your own tail, especially if like food pops where you are like in your loop. So these are things you can kind of test and move. And one of the things I love about the Battlesnake arena is that when I create a game, I can test my basic strats against Chicken Snake. So let's just do a search here. There we go. Chicken Snake, the original. So if we take a look at a medium-sized board here with basic strats versus Chicken Snake, I recommend if you're building a snake, test it against some of these classic, famous snakes and see how it does. So let's see what happens here. So there we go. There's Chicken Snake doing what Chicken Snake does, up in the top corner, like looping. And it's going to defeat, I've run this game many times, it's going to defeat basic strats over and over again because Chicken Snake stays far away. Chicken Snake takes care of itself. And at some point, basic strats gets big and runs into a wall, runs into itself because it gets itself in a position where it doesn't have any other options. So something to note about how that defensive algorithm can really work. So everyone should build a Chicken Snake, study it, learn it, understand its ways. Sweet. So yeah, I ran these games a lot. It was fun. And poor basic strats does not stand up. So now talking about attack snakes or sort of aggressive snakes, there's a couple of like common ways you can go aggressive. One I call ramming snake, which is like deliberately seeking out head-to-head collisions with snakes that are smaller than you. So you're going to have to write a bit more logic that's like looking at the length of snakes. Maybe you're deliberately eating food to try and get bigger to make sure you have that size advantage. But like seeking that out and putting that into your decision-making process to try and like go for head-to-head collisions. Another strategy, which is a little less precise but can get a lot of good traction, is like a hungry snake. Like what happens if you steal all the food? What happens if you can kind of like trap other snakes in spaces that are small because you're so big and force them to hit a wall or itself or to kind of starve out? Or some sort of combination of those. And when you're really talking about aggressive strategies, you might even want to start thinking about transitional strategies or combinations. If you're building a ramming snake, you might need a chicken snake period in the early game to allow yourself to grow before you actually go seeking out conflict. So that's really lots of variables to hit. Like, do you get really big? Do you want to behave differently on different boards sizes? There's a lot of things you can think about and play with, and kind of dials you can tweak. And that combo can be really, really fun. You could be defensive at first and start to grow, and then go aggressive when you're big enough, or kind of go really chaotic when you're big enough to kind of mess around the board. So when you combine these things, those first 4 commits that you need around avoiding walls, avoiding hitting yourself, avoiding other snakes, and then building up these strategies of being defensive, being aggressive, being chaotic, you can kind of mix and match and really make your own unique snake. There's so much variation and possibility for exploration. Cool. I hope you're excited about building your snake. I hope your mind is full of possibilities and things you want to try. One thing that can come up, like, what about machine learning? How does this come into play? This is something that people talk a lot about around Battlesnake, and we've only hit these beginning strategies. And if you are at the point now where you're ready to start thinking about phrases like possible future board states and like trying to predict what other snakes on the board might do or might not do, and if you want to like choose your move based on the likelihood that any given square will be occupied, then you probably want to start looking at machine learning. But even if that's your ultimate goal, I really want to encourage you to do these early stages first, because when you're working with machine learning, there's a lot to be said for having experienced it and like gone through the process and confront the scenarios and the different possibilities and different cases that your snake can get into by doing it manually. It's going to be a huge learning boost, and it's going to give you a lot of experience to then help you make good choices when you're tweaking a more complicated machine learning algorithm. It's really important to understand how all of the individual parts work before you start combining them in an algorithm that maybe is harder to understand. So definitely start with these. Do this first. These are the first things you should be doing with your snake. Machine learning is beyond the scope of what I'm talking about today, but there was a fantastic talk earlier today at 2 p.m. on Amazon SageMaker. There is a video stored as well, so you can go back and watch that. This is a great starter to kind of give you an idea of how to proceed with a machine learning snake and take those next steps. I also want to really encourage you tomorrow to watch the talk on Introduction to Design Thinking as well, which is, once again, pushing for more next steps. How do I modify my code, make changes, improve, identify problems? These are all skills that are going to help you. This is the beauty of Battlesnake. It takes a couple of hours maybe to get that first starter snake running. Maybe it takes you a few more hours to get those first 4 commits in. But we can keep going. There's so much to learn, so much to grow, so much to experiment with. So definitely check out some of the other talks this week. They will only improve you and expand the possibilities of what you can do. And finally, just kind of a plug here. If you like what I had to say today, if you enjoyed thinking about Battlesnake and are enjoying this competition, then I definitely want to echo what Brad opened with, which is, if you are able to, we would love to see some contributions to Food Banks Canada. Events like this are a lot of fun, and I love that we can rally together as a community to enjoy these programming problems, hone our skills, but also raise some money for a good cause. So that is me. Thank you all for hanging out with me and talking strategy and tactics. And I hope to see you on the 25th when we see the final tournament. I want to see your snakes in there.
Awesome. Thanks, Aurora. Is Hermit Colony going to participate in the tournament? Is that the plan?
I mean, I'm technically registered for the veteran category. I don't know how much more tweaking I'm going to get done before the end of the week, but we all feel great pride when, Curtis or Eileen or someone says your snake name. So I might want to achieve that kind of glory.
I think you have to let it ride and just see what happens. You're committed at this point. Yeah,
for sure.
I did want to touch base on a couple things. One, I really like that you mentioned machine learning at the end, because that is one way to evolve your snake. But I also want to add that there are some really good machine learning teams involved, but the machine learning snakes don't always win. In fact, every time we've run a Battlesnake tournament, it's been a hand-coded snake that's taken the first place prize every time. And I think a machine learning snake only came in second place once. So there's always new strategies being developed, new, like chicken snake. Chicken snake is a good example of this, of like an unexpected strategy that happens to do very well. There's always a ton of room for creativity, even if you're just hand programming your snake. And so we encourage everyone to do what's sort of most comfortable for them. Mm-hmm. I also, is Basic Strats public?
Yeah, Basic Strats is public in my GitHub repo. So my GitHub username is just Aurora Walker. I can pop to my first slide again. Well, whatever. Yeah, just Aurora Walker on GitHub. And you will see, the basic Python snake. It is all there and all of my commit history. So feel free to browse, see my glory, see my shame. We all have that in our commit history, and I am no different.
Awesome. All right. And the last thing I just want to ask you, how long did it take you to kind of get from, starting from scratch, starting from a starter snake, to getting to the point where like you were still losing repeatedly to chicken snake, but who doesn't do that? How long did it take you to get to that sort of final state?
Yeah, it took me 2 evenings, and I probably invested like maybe 5-6 hours. The bulk of that being those 2 bugs I had in the don't run into yourself wall. That off by 1 error and that dictionary copy thing actually caught me for the longest. So that commit, that section took the bulk of my time, and I was just, I don't know, I guess I was hungry or tired or whatever. But yeah, over 2 evenings, I was able to get going pretty quick and experimenting and, excited to take on the next step.
Yeah. And it got you viable in the veteran category, which is like veteran viable. That's not bad. It's not bad.
Not last. That's key.
That's the important part. Awesome. You want to just wrap up and tell everyone where they can find you and that sort of thing? Yeah.
Absolutely, yeah. So I am around on the internet a lot. So my GitHub is Aurora Walker, and my Twitter handle is @BillyThePunk, which is definitely a dumb in-joke, which is what we all use for our handles. But you can see me a lot as a part of Canada Learning Code, and as a part of Bambora at company events. So definitely feel free to reach out to me through either of those organizations, and especially through Canada Learning Code at this time. I instruct a lot for that, and we've definitely been porting our programming workshops to that online experience. So getting like a collaborative learning environment online has been a challenge, but the team is doing a great job. So online workshops are run, and that's perfect for folks who are new to programming and who are just sort of starting to experiment. They're designed for people who've never programmed before. So definitely encourage folks, if you have someone who's like looking over your shoulder, thinks Battlesnake's kind of interesting, definitely check out canadalearningcode.ca. There are online experiences happening that start teaching the fundamentals of programming. Still expanding, we're still porting some of our workshops to the online experience, but definitely something to check out over the coming months.
Awesome. Thank you so much. And it's been a really great time. Thanks for coming out.
Yeah, thanks for having me. It's been fun, everyone. I'm excited to see what you build.
And with that, I think that's all we have for now. And so thanks so much for watching. Thanks again to Aurora, and we'll see you all later.